Yes, myself Hemant. I am from Sri College of Engineering, Bengaluru. I am studying in third year, fifth sem, EC department. Today we will learn about semiconductor of memories. First thing is about memory, and all actual computing starts with the CPU of central processing unit. The chipset supports the CPU and contains several controllers that control how information travels between CPU and other components in the PC. The memory controller is part of the chipset and establishes the information flow between memory and the CPU. The bus is a data path that consists of parallel wires and connects the CPU, memory, and other devices. The bus architecture determines how much and how fast the data can move around the motherboard. The memory bus goes from the memory controller to the computer memory sockets. Newer systems have a front side bus FSB from the CPU to main memory as a backside bus, the BSB, from the memory controller to L2 act cache memory. The role of memory during boot up is when you turn on the computer means the computer loads data from read-only memory ROM and performs a power on self test means post to make sure all the major components are functioning properly. As part this test, the memory controller checks all the memory addresses with a quick read and write operation to ensure that there are no errors in the memory chips. Read write means that data is written to be a bit and then read from the bit. The computer loads the basic input output system BIOS from the BIOS provides the most basic information about storage devices and boot sequence security plug and play auto device recognition means recoverability and a few other items. The computer loads the operating system OS from the hard drive into the system RAM. Generally, the critical parts of the operating system are maintained in RAM as long as the computer is on. This allows the CPU to have the immediate access to the operating system, which enhances the performance and functionality of the overall system. The role of memory during boot up, like main concept in that is when you open application, it is loaded into a RAM to ensure RAM to conserve RAM usage. Many applications load only essential parts of the program initially and then load other pieces are as needed. After an application is loaded, then and any files that are open for use in that applications are loaded into RAM. Where when you save a file and close the application, the file is written to the specific storage device, and then it is and the application are plugged from RAM. And the main memory is of the CPU first level CPU register and cache memory level 1 level 2, and then it reaches the RAM, physical memory and virtual memory. Then it registers the storage device types like ROM, BIOS, or removable drives and network internet storage or hard drive. And then it registers the input sources like keyboard, mouses, removable media, scanner, camera, mic, or a mic, or any video, and also a remote source, or other source also. The primary stage, and there are two types of storage stages: primary storage and secondary storage. In computer memory hierarchy, it means computer size or in some small capacity, medium capacity, a small large capacity, large size, very large capacity, large size, very large capacity. And based on these types, they are all something that has power on very short term, power of very short term, power of mid term, and power of on long term. And then also certain examples are there. For a small capacity processor registers very fast, very expensive. As medium size their processor cache very fast, expensive. As a small size large capacity random access memory and fast, affordable. And small size large capacity also there's an flash USB, slow and cheap. And also large size very large capacity as a hard drives and slow, very cheap. And also the large size and very large capacity is CD, DVD, taped, and backup, very also affordable. And memory structure is mainly different of memory in the ROM, and also flash, the hard disk, and by the help of non-volatile. And there are two types of memories, and volatile memory and non-volatile memory. Volatile, there is of RAM, and in RAM there is a two type, static and dynamic. And ROM, in there is a two type, PROM, EPROM, or double PROM. A flash, there are two types, NOR and NAND. Based on that two gates, you are going to operate that. And volatile memory, they are DRAM, for example, DRAM, STRAM, this is the dynamic memory. And SRAM is cache memory, static memory. The evolution of memories are mainly it's of 1987 to 1996 are based on FPM, EDO, P66 ST-RAM, and also ROM PC136 ST-RAM, DDR ST-RAM, DDR2 ST-RAM, DDR3. So based on that hertz only, it's only first it will be 15 nanoseconds, and second it also 15 nanoseconds, and then goes on increasing like 66 megahertz, 40 400 megahertz, like a 130 1066 gigahertz, 46 megahertz, 400 megahertz. So it lastly finally it's about for 800 megahertz. That RAM, it takes takes the form of integrated circuit that allows store data to access the RAM, means random access memory. It takes from the integrated circuit that allow the stored data to be accessed in any order, regardless of the memory location that we last access. RAM generally stores a bit of data in either the state of flip flop, as in SRAM, as a charge in capacitor or transistor gate, or in a DRAM, dynamic RAM, or flash. Sometimes some types have security to detect and or correct random faults called memory errors in the stored data using parity bits or error correction codes. RAM of the read only type. RAM instead just metal must permanently enable or disable selected instead of storing a charge in them. SRAM, static random access memory, use multiple transistors, typically for 4 to 6 of each memory cells, but doesn't have a capacitor in each cell. It is used to memory cells for cache. Static indicates that unlike dynamic RAM or DRAM, does not need to be periodically refreshed, as a SRAM uses bistable latching security to store each bit, and SRAM cells has three different states. It can be in it can be in standby, where the circuit is idle, ready waiting when the data has been requested, and rating when operating the contents. Cache memory is a relatively small amount that normally less than 1 MB of high speed memory, and resides very close to the CPU. It is designed to supply the CPU with the most frequently requested data. It takes a fraction of the time compared to the normal memory to access the cache memory. The cache memory, it's of like this block diagram, like a main memory and cache memory. And when 0 is directly connected with the index 0 1 to index 1 to index 2 to index 2 3 to index 3, then 4 and 5 means again the order it will be remitting between memory and cache memory. This means means DRAM, dynamic random access memory. DRAM means access memory. It's just memory cells with a period transition and capacitor fetching constant refreshing. Types of DRAM. STRAM is a synchronous dynamic random access memory. Takes advantage of the burst mode. Because it will greatly improve in performance. It does this is by staying on the row containing the requested bit and moving rapidly through the columns, reading each bit as it goes. The idea is the most of the time the data needed by the CPU will be the during the sequence. STRAM is about 5% faster than the EDO RAIU, and it is the most common forms in desktop today. Maximum transfer rate is L2 cache is approximately 528 MB per second. DDR STRAM means double data rate, synchronous dynamic RAM. It is just like a ST RAM, expect that it's a higher bandwidth, meaning greater the speed, and maximum transfer rate is L2 cache is approximately 1.64 MB per second. For DDR STRAM is 133 megahertz. Types of DRAM is RDRAM. The Ramos dynamic random access memory is a radical departure from the previous DRAM architecture designed by Rambus. DRAM uses Rambus in a line memory module, RAM, which is similar in size and pin configuration as to a standard DIMM, which makes RDRAM so different. Is its use of a special high speed data bus called that Rambus channel. The RDRAM memory chips work in a parallel to achieve the data rate of 800 megahertz or 1600 MB per second. Since they operate to such high speeds, they generate much more heat than the other type of chips. To help dissipate the excess heat, Rambus chips and fed with the heat spreader, which looks like a long thin wafer. Just like there is a smaller versions of DIMMs, and there are also so RIMs designed for notebook computers. Credit card memories are proprietary self contained DRAM memory module, plugs in a special slot for using a notebook computer, or PCMCIA memory card, other self-contained DRAM module for notebooks, card for this type, and they're not proprietary, and should work within any notebook computer whose system bus matches the memory card's configuration. The additional use of RAM is RAM disk. So software can partition of computer RAM, allowing the access much faster, and hard drive that is called as RAM disk. Um, Unless the memory is not idle, a RAM disk loses stored data. If a computer is shut down, however, idle memory can retain the data when the computer is shut down. If it's a separate power source, usually a battery swapping it. If a computer becomes a low or an RAM during intense application cycles, the computer can resort to swapping. In the case the computer temporarily uses hard drive spaces as additional memory, constantly relying on this type of backup memories is called caching, which is generally undesirable because it lowers overall system performance. In order to reduce the dependency on swapping, more RAM can be installed. Non-volatile memories are basically electrically addressed ROM, PROM, EAROM, EPROM, EEPROM, flash memory, nor and mechanically addressed systems are tape, hard disk, optical disk, and magnetic disk. The ROM, it mainly ROM is to store program computer store sorry um RAM mean for store program computer requires some form of a non-volatile storage to store the initial program that runs when the computer is powered on, and otherwise begins execution. A process known as bootstrapping or often updated to booting or booting up. Only read-only memory ROM, also known as firmware, is integrated circuit programmed with specific data. When it is manufactured, ROM chips are used not only in computers but also most of the electronic items as well as the PROM. The main advantage of PROM are reliability, store data inventory, moderate price, built using integrated circuits rather than the discrete components, and fast is between 35 nanoseconds to 60 nanoseconds. And what the main PROM is, programmable read-only memory, means that creating a ROM chips totally from scratch is time consuming with very expensive small quantities. For this reason, mainly developers created a type of ROM known as like PROM, means a programmable read-only memory. That blank programmable read-only memory chips can be bought inexpensively and closed and coded by anyone with a special tool called programmer. And EPROM means erasable programmable read-only memory. It's an array that of floating gate transistors individually programmed by an electronic device that supplies higher voltage than those normally used in electron circuits. Once programmed, EPROM can be erased only by exposing it to strong ultraviolet light. Working with ORM and PROM can be wasteful business. Even though there is an inexpensive per chip, the cost can be the cost can add up over time. Erasable programmable read-only memory the addresses this issue. EPRM chips can be rewritten many times. Erasing uh, requires a special tool that emits a certain frequency of ultraviolet light. EPROM can configured using a programmer that provides voltage and at specified levels depending on the types of EPROM used. EPROM also easily recognizable by the transparent fused quartz window in the top of the package through which the silicon chip can be seen, and which permits UV light during erasing. Even though EPROM are a big step up from EPROM in terms of reusability, they still require dedicated equipment and labor intensive process to remove and reinstall them. Each time as a change is necessary. Also, changes cannot be made in them, incrementally. So to an EPROM, which also chipset is electrically usable programmable read-only memory, which removes the biggest drawbacks of a erasable electrically erasable programmable read-only memory. In the chip does not have to remove to be written, and the entire chip does not have to be completely erased to change a specific portion of it. Changing the contents does not require additional dedicated equipment. And failure modes of electrically erasable programmable read-only memories. There are two limitations: stored information ignorance or data tension. During rewrites, the gate oxide in the floating gate transistors gradually accumulates trapped electrons. The electric field to be trapped electrons adds to electron in the floating gates, lower in the window between threshold voltages for zeros and ones. After a sufficient number of rewrite cycles, the difference between becomes too small to be recognizable. The cell is stuck in programmable state and endurance failure occurs. The manufacturer usually specify minimum number of rewrites being from 1 crore or more to more. During storage, the electrons injected to the floating gate by mid-drift that insulator, especially at increased temperature, and cause charge loss and reverting the cell into a erased state. The manufacturers usually guarantee data retention at 10 years. The comparison is EPRM means erasable programmable retention memory or electrically erasable programmable retention memory. It requires highest cost also and low reliability but lower density. And also flash memory, it's also a full feature and memory solution. And ROM also high density, reliable and low cost, so suitable for a suitable code production. And DRAM, high density, low cost, high speed and high power. And flash memory is a low cost, low density and high speed architecture and lower power and high reliability. These are the recommended memories. The memory and these are the recommended memories. And my main thing is the memory terminology. The memory speed is measured in nanoseconds. This is the time to be accessed data that is stored in memory. The lower of nanosecond, the faster is the memory. So 2 nanoseconds to 18 nanoseconds. And parity, the simple error checking method used to used for memory correction. And the ECC means error correction code you are using memory creation for newer computers. Memory banks are a socket where memory is installed. Example, 4 banks will not have a 256 MB of memory, each of a total of 1 GB. The memory troubleshooting is EST and mixed means low and high humidity. Mixed memory usually equals fine memory and parity errors and ECC errors. And general production fault, not enough memory. NMI means non-maskable. Interrupt will cause BSOD. Multiple beeps when booting up. Check the memory is properly installing and working. And no video. And the memory speed set in BIOS or CMOS setup, the virtual memory and chip creep. And concluding aspect is the more memory the better. The must sync with the processor speed. This is the concluding aspect. These are the references, and thankful for watching my video.